The first 10 minutes of your day are not what you think they are. You wake up, reach for your phone, scroll through notifications, maybe grab a coffee, and you believe you're starting your day. But what's actually happening in those moments is far more profound than a simple routine. Your brain is running a boot sequence. It's initializing systems that will determine how fast you think, how clearly you process information, and how efficiently you solve problems for the next 16 hours. And here's the thing nobody tells you. This initialization process is not random. It follows rules, strict mathematical rules. The same kind of rules that Alan Turing spent his life trying to understand about computation itself. You see, Turing didn't just invent the computer. He asked a question that changed everything. What can be computed? What are the limits of calculation? What separates a problem that can be solved from one that cannot? And when you understand his answer to that question, you suddenly understand why those first 10 minutes of your morning matter so much. Because your brain, like any computational system, has limits. It has bandwidth, it has processing speed, and the way you initialize it determines everything that follows. Most people think the morning is about motivation. They think it's about willpower, about forcing yourself out of bed, about positive thinking. That's the comfortable lie we tell ourselves. The truth is colder, more logical, more mathematical. The morning is about input. It's about what data you feed into your system before it reaches full operational capacity. It's about understanding that your mind, like Turing's machine, processes information in a specific sequence with specific constraints, and those constraints are not negotiable. They're not something you can overcome with determination. They're fundamental to how cognition works. This is where most productivity advice fails. It treats your brain like it's infinitely flexible, like you can reprogram it through sheer force of will. But Turing proved something different. He proved that there are problems that no algorithm can solve, no matter how powerful the machine. There are limits, and understanding those limits is not depressing. It's liberating, because once you know the boundaries of what's possible, you can work within them, you can optimize, you can become genuinely efficient instead of just busy. The question I want to explore with you today is this: what if the first 10 minutes of your morning are not about motivation or discipline, but about understanding the computational architecture of your own mind? What if the reason you feel mentally sluggish by noon is not because you lack willpower, but because you initialized your cognitive system with the wrong input? What if the people who seem to think faster, solve problems more elegantly, and maintain mental clarity throughout the day have simply figured out the algorithm? Let me take you back to 1936. Alan Turing is sitting in Cambridge, and he's wrestling with something called the Entscheidungsproblem, the decision problem. David Hilbert, one of the greatest mathematicians of the era, had posed a fundamental question: is there a mechanical procedure, a step-by-step algorithm, that can determine whether any mathematical statement is true or false? It sounds simple. It sounds like it should be possible. But Turing proved it wasn't. He proved that some problems are fundamentally unsolvable by any computational process, no matter how much time or resources you give it. How did he prove this? By inventing something that didn't exist yet, a theoretical machine, a machine with an infinite tape, a read-write head, and a set of simple rules. This machine could move left or right on the tape, read symbols, write symbols, and change its internal state based on what it read. That's it, those simple operations. And Turing showed that this simple machine could compute anything that was computable. Anything. He called it the universal machine, and here's what's crucial. He also showed that there were things this machine could never compute. Problems that would cause it to loop forever, never reaching an answer. The halting problem. Can you determine whether a program will ever finish running, or will it loop infinitely? Turing proved that no algorithm could answer that question. Now, why does this matter for your morning? Because your brain is also a computational system. It has processing speed. It has bandwidth. It has states it can enter. And just like Turing's machine, it has limits. You cannot think faster than your neural architecture allows. You cannot process more information simultaneously than your working memory can hold. These are not limitations you can overcome with coffee or cold showers. They're fundamental. They're mathematical. They're real. But here's what Turing also proved. Within those limits, you can be incredibly efficient. The universal machine could compute anything that was computable. It wasn't the fastest machine. It wasn't the most elegant. But it was universal. It could solve any solvable problem. And your brain, in those first 10 minutes of the morning, is initializing which version of itself it's going to be. Are you initializing the universal processor ready to tackle complex problems? Or are you initializing a machine stuck in a loop, endlessly refreshing social media, unable to break the cycle? The Enigma machine during World War II is a perfect historical example of this principle in action. The Nazis believed their encryption was unbreakable. They had a machine with millions of possible configurations. But Turing and his team at Bletchley Park understood something crucial. The problem was solvable. It wasn't a halting problem. It wasn't an unsolvable decision problem. It was a computational problem with a solution, and they just needed to find the right algorithm, the right sequence of steps to crack it. They built the bomb machine, a device that could test thousands of configurations per minute. And they did something remarkable. They saved an estimated 14 million lives by decrypting German communications. But notice what happened there. The Nazis had more computing power in raw terms. They had more machines, more people, more resources. What they didn't have was the right algorithm. They didn't have the right sequence of operations. They didn't understand the computational structure of their own problem. Turing did. And that understanding, that clarity about how information flows and how problems can be decomposed, made all the difference. This is exactly what happens in your morning. You have a certain amount of mental energy. You have a certain processing capacity. You have a certain amount of time before your brain reaches decision fatigue. These are your constraints. Just like Turing's machine had constraints, the question is, are you using an algorithm that works within those constraints, or are you wasting your computational resources on tasks that don't matter? Most people wake up and immediately feed their brain the wrong input. They check their phone. They see notifications from dozens of sources. They read news headlines designed to trigger emotional responses. They see messages from people demanding their attention. And what they've done, without realizing it, is initialize their cognitive system in a state of reactive processing. Their brain is now in a loop, responding to external stimuli, unable to break free and enter a state of deep, focused computation. They've essentially created their own halting problem. They're stuck in a loop, and no amount of willpower will get them out, because the loop is baked into the initialization sequence. The first 10 minutes of your day are your initialization sequence. They're the moment when your brain is booting up, when it's establishing which neural pathways will be dominant, which neurotransmitters will be prioritized, which cognitive modes will be available to you. And this is not metaphorical. This is neuroscience. Your prefrontal cortex, the part of your brain responsible for executive function, planning, and complex problem-solving, takes time to fully activate after sleep. It's not running at full capacity the moment you wake up. It's initializing. And what you do during that initialization determines how efficiently it will run. Here's a question for you. If you were Alan Turing and you had just proven that some problems are unsolvable, that some loops are infinite, that some systems will never reach a solution, what would you do with that knowledge? Would you spend your day trying to solve unsolvable problems, or would you focus your energy on problems that are actually computable, that have solutions, that your mind can actually reach? I'm genuinely curious what you think about this, because most people spend their mornings on the unsolvable problems. They check their email, which is an infinite stream. They scroll social media, which is algorithmically designed to be unsolvable, to keep them in a loop forever. They respond to messages, which multiply faster than they can process them. They're trying to solve the halting problem every single morning, and they wonder why they feel exhausted by noon. Now let's go deeper into what actually happens during those first 10 minutes. Your brain is not a single processor. It's a parallel system with multiple modes of operation. You have your default mode network, which activates when you're not focused on external tasks, when you're daydreaming or thinking about yourself. You have your task-positive network, which activates when you're focused on external problems. You have your salience network, which determines what's important and what you should pay attention to. These networks don't all activate at the same time. They compete for resources, and the way you initialize your morning determines which networks will dominate. When you wake up and immediately check your phone, you're forcing your task-positive network to activate before your default mode network has had time to do its job. Your default mode network is crucial for creativity, for making novel connections, for integrating information from the previous day's experiences. It's the network that does the deep processing, the consolidation, the meaning-making. But if you interrupt it by forcing external task focus, you're essentially telling your brain, forget about integration, forget about creativity, forget about meaning, just react to external stimuli. And your brain, being a computational system that follows rules, does exactly that. It switches modes. It prioritizes the task-positive network. And now you're in reactive mode for the rest of the day. This is where Turing's insight becomes practical. He understood that computation is not just about raw processing power. It's about the sequence of operations. It's about the order in which you feed information into the system. The same machine, running the same algorithm, but with inputs in a different order, can produce completely different results. Or it can get stuck in a loop, or it can reach a solution much faster. The sequence matters. The order matters. The initialization matters. Think about the Turing test, his famous thought experiment about machine intelligence. He asked, can a machine imitate a human in conversation so perfectly that you can't tell the difference? And he argued that if a machine could do that, then it would be fair to say the machine is thinking. But notice what he was really asking. What is the minimal set of operations required to produce intelligent behavior? What's the algorithm? And his answer was, it's not about consciousness. It's not about some magical inner experience. It's about the ability to process information, to respond appropriately to input, to maintain coherence in a conversation. It's about the algorithm. Your morning is your Turing test. Can you initialize your cognitive system in a way that produces intelligent behavior? Can you set up your morning so that your brain is actually thinking, actually processing, actually solving problems? Or are you just reacting, just responding to stimuli, just running a loop? The difference is not in the hardware. You have the same brain whether you check your phone first thing or whether you sit in silence for 10 minutes. The difference is in the algorithm. The difference is in the sequence of operations. The difference is in what you feed into the system first. Here's what the research actually shows. Studies on decision fatigue conducted by researchers like Roy Baumeister demonstrate that your capacity for complex decision-making is limited. You have a certain amount of cognitive resources available each day, and they deplete as you make decisions. The more decisions you make early in the day, the worse your decisions become later. This is not willpower. This is not motivation. This is computational capacity. You have a finite amount of processing power, and once you've used it up, you're done. You can't think clearly anymore. Your brain is running on fumes. But here's the crucial part. Not all decisions are equally expensive. Some decisions are cheap, some are expensive. Checking your phone is cheap in terms of cognitive load, but it's expensive in terms of decision fatigue because it triggers a cascade of micro-decisions. Should I respond to this message? Should I click on this link? Should I read this article? Each one is a small decision, but they add up. By the time you've spent 10 minutes on your phone, you've made hundreds of micro decisions and you've depleted a significant portion of your daily cognitive budget. On the other hand, sitting in silence, meditating, or doing focused work on a single complex problem is expensive in terms of cognitive load, but it's cheap in terms of decision fatigue because you're making one big decision. I'm going to focus on this problem. And then you're just executing that decision. You're not constantly reevaluating. You're not constantly switching contexts. You're running a single algorithm, and you're running it efficiently. This is the computational structure of the morning. This is why the first 10 minutes matters so much, because you're not just starting your day. You're initializing your cognitive system. You're determining how much of your daily processing capacity you're going to waste on cheap decisions versus how much you're going to preserve for expensive, important decisions. And once you understand this, once you understand that your brain is a computational system with limited resources, you can start to optimize. The people who seem to think faster, who seem to solve problems more elegantly, who seem to maintain mental clarity throughout the day, they've figured out the algorithm. They've figured out how to initialize their morning in a way that preserves their cognitive resources. They're not checking their phone first thing. They're not jumping into email. They're not reacting to external stimuli. They're doing something that looks simple but is actually profound. They're giving their brain time to initialize properly. Some of them meditate. Some of them exercise. Some of them write. Some of them just sit in silence. The specific activity doesn't matter as much as the principle. They're not feeding external input into their system during the initialization phase. They're letting their default mode network do its job. They're letting their brain consolidate information from the previous day. They're letting their prefrontal cortex fully activate. And then, once that initialization is complete, once their cognitive system is running at full capacity, they start feeding in external input. They check their email, they respond to messages, they tackle their to-do list. But by that point, they're not in reactive mode. They're in proactive mode. They're not trying to solve the halting problem. They're solving actual problems that have solutions. Now, let's talk about what this means for modern technology and modern life. We live in an age of infinite input. Your phone is a device designed to feed you an infinite stream of information. Social media platforms are engineered to keep you in a loop, endlessly scrolling, endlessly consuming, endlessly reacting. Email is an infinite stream of demands on your attention. News is a constant flow of information designed to trigger emotional responses. And all of this is happening in your pocket, available the moment you wake up. This is unprecedented in human history. For most of human evolution, the morning was quiet. You woke up, and there was no input except what was immediately around you. Your brain could initialize naturally, it could do its consolidation work, it could prepare for the day. But now, the moment you wake up, you have access to the entire world's information, and it's all demanding your attention. And most people, without even thinking about it, immediately feed all of that input into their system during the initialization phase. They're essentially trying to boot up their computer while simultaneously downloading 1,000 files. Of course it's slow. Of course it crashes. Of course they feel mentally exhausted by noon. The solution is not to reject technology. It's to understand the computational structure of your own mind and to use technology in a way that respects that structure. It's to recognize that your brain has an initialization phase, and during that phase, you should be very selective about what input you allow. It's to recognize that you have limited cognitive resources, and you should be strategic about how you allocate them. It's to recognize that the first 10 minutes of your day are not just the beginning of your day. They're the initialization sequence that determines how efficiently your entire cognitive system will run. Think about it this way. If you were designing a computer system and you knew that the initialization sequence determined the performance of the entire system, would you allow random files to be downloaded during initialization? Would you allow the system to be bombarded with requests while it was booting up? Of course not. You'd protect the initialization phase. You'd make sure the system had time to fully boot before you started feeding it external input. You'd optimize the initialization sequence because you understand that it determines everything that follows. Your brain is the same. It's a computational system. It has an initialization phase. And the way you handle that phase determines how efficiently it will run for the rest of the day. This is not about motivation. This is not about discipline. This is about understanding the mathematical structure of cognition and working within it instead of against it. Here's what's fascinating. This principle extends far beyond just the morning. It applies to any time you're switching between different cognitive modes. When you finish a deep work session and switch to email, you're reinitializing your cognitive system. When you finish a meeting and go back to focused work, you're reinitializing. Every context switch is a mini initialization, and every initialization has a cost. This is why multitasking is so cognitively expensive. You're constantly reinitializing your system, constantly switching algorithms, constantly wasting processing power on the switching itself rather than on the actual computation. But the morning is special because it's the first initialization of the day. Your brain is coming out of sleep, which is a completely different mode of operation. Your prefrontal cortex is not fully activated. Your working memory is not at full capacity. Your attention networks are not fully engaged. You're in a vulnerable state, computationally speaking, and what you do during that vulnerable state determines how robust your cognitive system will be for the rest of the day. This is where we connect back to Turing's deeper insight. He understood that computation is not magic. It's not mysterious. It's not something that happens in some ineffable inner realm. It's a process. It's a sequence of operations. It's rule-based. It's deterministic. And once you understand the rules, once you understand the sequence, you can optimize it. You can make it more efficient. You can make it more powerful. Your morning is the same. It's not magic. It's not about willpower or motivation or positive thinking. It's about understanding the computational structure of your own mind and initializing it in a way that respects that structure. It's about recognizing that you have limited resources and being strategic about how you allocate them. It's about understanding that the first 10 minutes of your day are not just the beginning. They're the foundation. They're the initialization sequence that determines everything that follows. The people who seem to have it figured out, who seem to think clearly and solve problems elegantly and maintain mental energy throughout the day, they've understood this principle. They've figured out their own algorithm. They've figured out how to initialize their cognitive system in a way that works for them. And the good news is, you can do the same. You don't need to be a genius. You don't need to have special talents. You just need to understand the principle and apply it. So here's my question for you, and I want you to really think about this. What is your current morning initialization sequence? What's the first thing you do when you wake up? What input are you feeding into your system during that vulnerable initialization phase? And more importantly, is it actually serving you? Is it setting you up for a day of clear thinking and efficient problem solving? Or is it setting you up for a day of reactive processing and decision fatigue? I'm genuinely curious what you think, because this is not a trivial question. This is about how you spend your mental energy every single day. This is about whether you're optimizing your cognitive system or sabotaging it. Leave a comment and let me know what your morning looks like. What's the first thing you do? And more importantly, why? Because I think the answers to those questions will tell you everything you need to know about why you think the way you think. If you've made it this far, you understand something that most people don't. You understand that your mind is not some magical entity that operates outside the laws of computation. You understand that it's a system, it's a process, it's something that can be understood and optimized. And that understanding is powerful. So if this resonates with you, if you're starting to think about your morning differently, hit that like button. It helps the algorithm understand that this kind of content matters. And subscribe, because we're going to keep exploring these ideas. We're going to keep digging into the computational structure of human cognition. We're going to keep finding ways to optimize how you think and work and create. And if you want to be notified every time we upload, hit that notification bell. Because these ideas, these principles, they're going to change how you approach your entire day. Now let's talk about what happens when you actually implement this. Let's talk about the real-world implications of understanding your morning as an initialization sequence. Because this is where theory meets practice. This is where the abstract principle of computational efficiency becomes concrete, actionable, transformative. The first thing you need to understand is that there's no one-size-fits-all algorithm. Turing proved that the universal machine could compute anything that was computable, but he didn't say that every machine should run the same program. Different problems require different algorithms. Different people have different cognitive architectures. What works for one person might not work for another. The principle is universal. Protect your initialization phase, preserve your cognitive resources, be strategic about input, but the specific implementation is individual. Some people find that meditation is the perfect initialization ritual. They sit in silence for 10 minutes, and their default mode network does its consolidation work. Their prefrontal cortex fully activates. Their attention networks stabilize. And then they're ready to engage with the world. Other people find that exercise is the perfect initialization. They go for a run or do some yoga, and the physical activity seems to activate their cognitive systems in a way that sitting in silence doesn't. Other people find that writing is the perfect initialization. They journal for 10 minutes, and the act of externalizing their thoughts seems to organize their mind. The specific activity varies, but the principle is the same. You're protecting your initialization phase. You're giving your brain time to fully boot before you start feeding it external input. The second thing you need to understand is that this is not about perfection. You don't need to have a perfect morning every single day. You don't need to meditate for exactly 10 minutes or exercise for exactly 30 minutes. You don't need to follow some rigid protocol. The principle is flexible. It's about being intentional. It's about recognizing that your morning matters and making conscious choices about how you spend it. Some days you might have time for a full initialization ritual. Other days you might only have 5 minutes. That's fine. 5 minutes of intentional, protected time is better than 0 minutes. The key is consistency and intention. The key is recognizing that your morning is not just something that happens to you, it's something you can design. It's something you can optimize. The third thing you need to understand is that this has real, measurable effects. This is not just philosophy. This is not just theory. There's actual neuroscience behind this. Studies show that people who have a consistent morning routine have better emotional regulation, better focus, better decision-making throughout the day. Studies show that protecting your morning from external input improves your cognitive performance. Studies show that the order in which you process information affects how efficiently you can solve problems. This is not wishful thinking. This is not positive psychology. This is computational neuroscience. This is how your brain actually works. The fourth thing you need to understand is that this is a competitive advantage. In a world where everyone is constantly connected, constantly reacting, constantly in a state of decision fatigue, the people who have figured out how to protect their initialization phase have a massive advantage. They're thinking more clearly. They're solving problems more elegantly. They're maintaining mental energy while everyone else is burning out. They're not smarter. They're not more talented. They're just using a better algorithm. They're just initializing their cognitive system in a way that actually works. And here's the thing, this advantage compounds. Because when you're thinking more clearly, you make better decisions. And better decisions lead to better outcomes. And better outcomes lead to more confidence and more motivation. And more confidence and motivation lead to better execution. And better execution leads to better results. It's a positive feedback loop. It's a virtuous cycle. And it all starts with how you spend the first 10 minutes of your day. This is why Turing's work matters so much, even today, even in contexts that have nothing to do with computers or mathematics. Because Turing understood something fundamental about how systems work. He understood that the structure matters, the sequence matters, the initialization matters. And once you understand that principle, you can apply it to anything. You can apply it to your morning. You can apply it to your work. You can apply it to your relationships. You can apply it to your entire life. The morning is just the beginning, but it's the most important beginning because it sets the tone for everything that follows. It determines how efficiently your cognitive system will run. It determines how much mental energy you'll have available for the things that matter. It determines whether you'll spend your day in reactive mode or proactive mode. It determines whether you'll be solving actual problems or stuck in loops. So the real question is not whether the first 10 minutes of your day matter. They obviously do. The real question is, what are you going to do about it? Are you going to continue with your current morning routine, whatever it is, without thinking about it? Or are you going to take control of your initialization sequence? Are you going to design a morning that actually works for your brain instead of against it? Are you going to protect that vulnerable initialization phase and give your cognitive system the time it needs to fully boot? Because once you do, once you understand that your morning is not just the beginning of your day, but the initialization sequence that determines how efficiently your entire cognitive system will run, everything changes. You start thinking differently. You start working differently. You start living differently. And it all comes from understanding a simple principle. The first 10 minutes matter. The initialization sequence matters. The input you feed into your system during that vulnerable phase determines everything that follows. This is the legacy of Alan Turing, not just the computer, not just the algorithm, but the understanding that systems work according to rules, that computation is not magic, that efficiency comes from understanding structure and respecting constraints, that the sequence matters, that the initialization matters, and that once you understand these principles, you can optimize anything. You can optimize your morning. You can optimize your thinking. You can optimize your life. The choice is yours. You can wake up tomorrow and do what you've always done. You can check your phone. You can jump into email. You can start reacting to external stimuli. And you can spend the rest of your day in a state of decision fatigue and reactive processing. Or you can take control of your initialization sequence. You can protect your morning. You can give your brain time to fully boot. You can preserve your cognitive resources for the things that actually matter. And you can spend the rest of your day thinking clearly, solving problems elegantly, and maintaining mental energy. The difference is not in the hardware. You have the same brain either way. The difference is in the algorithm. The difference is in the sequence. The difference is in understanding that your morning is not just the beginning of your day. It's the foundation. It's the initialization sequence. It's the moment when you decide what kind of cognitive system you're going to be. And that decision, that simple decision about how you spend the first 10 minutes of your day, might be the most important decision you make all day long. Educational note. This Rotero combines scientific principles of neuroscience and cognitive psychology with philosophical concepts from Alan Turing's work on computation and machine intelligence. While the narrative uses Turing's theoretical framework as a lens for understanding morning cognition, the specific claims about morning routines and cognitive efficiency are based on established research in neuroscience and decision fatigue studies. The content is designed for educational entertainment purposes, blending rigorous concepts with accessible storytelling.